all the speakers highlighted the condition of PVC in the country and the globe, the amount of deficit that is there, the handicaps and all that. In today's sessions, we are going to address some of those things. One of them is, if you want to set up new capacity, you need ethylene. Without ethylene, how will you set up? And ethylene means you need to have a cracker, and if you have to have a cracker, then the investment is huge, and it cannot be only cracker. There's an entire downstream.
I'm David Milroy. I'm a licensing manager for Johnson Matthey in the UK. And what I want to talk to you today is I want to introduce how our mercury-free PVC technology can help India satisfy its ever-growing demand for PVC. So by way of an introduction to Johnson Matthey, Johnson Matthey is a UK-based company headquartered in London. We've been around for a long time, 208 years. Our roots were in precious metal trading and assay. However, over the last 2 centuries, we've evolved to become a diverse business offering cutting-edge products and solutions across a wide variety of markets, most notably in automotive emission control, catalyst systems, and also what I'm going to talk to you today about as a technology licensor in the chemical sector. And you can see from this slide in front of you just now, we offer a broad portfolio of licensed technology across the syngas technology space, sustainable fuels, and chemical intermediates. And what I want to talk to you specifically today is our vinyl chloride monomer, or VCM technology, which adopts a mercury-free catalyst. So just to start off by way of an introduction to the topic, so I think we all know that PVC is one of the most versatile and widely used polymers in the world, which can feed into a variety of applications, across a vast array of industries. Now, PVC is traditionally produced via 2 established routes. The first one is from what I would call the acetylene-based PVC route, or some of you may refer to it as the carb-based.
Alkali industry is the alkali-chlorine balance. While producing 1 ton caustic soda will generate about 0.886 ton chlorine gas. Chlorine gas is a hazardous chemical that is inconvenient to store and transport and carries high risks. It must be converted into chlorine-consuming products within a short period after production. Liquid chlorine is mainly used in the production of PVC, methane chloride, hydrochloric acid, etc., with PVC being the largest demand area, accounting for about 50%. Besides PVC, there are also some other common chlorine-consuming products. Here are below are the chlorine consumption figures for them. We can compare from the chlorine consumption, technical difficulty, and market status about several common chlorine-consuming products. You can see for the PVC, CPE, and epichlorohydrin, at present the market is increasing, and for the technical difficulty, it's medium or medium high. Maybe this is most suitable for all the chlor-alkali companies. And also there are some common products the market is stable, such as the calcium hypochlorite, chlorinated paraffin. Also the TCCA, also in the increasing market. And there is a highly increasing market product.
We are presenting today process water recovery and reutilization in PVC production, driving utility efficiency and emission reduction. As all of you know, we are living in turbulent and challenging times. So we talked about it yesterday a lot. And it seems that topics like supply security and availability of raw materials will become more important than specific aspects of sustainability. So was sustainability then only a hype? And is it over now? With our presentation today, we would give a clear answer to this question: no, it is not. thyssenkrupp Uhde is a German engineering company with a global footprint. We are proud to be active with our technology portfolio for more than 100 years in the following 3 fields: fertilizers for sustainable agriculture and ammonia derivatives, transformation of green energy into fuels, and circular.
So here on the right side you can see a map of the global water stress level, which means the ratio of water demand to water supply from renewable sources. And in deep red color you can see all regions with a water stress level over 80%. And you can see there are quite a lot of regions in the world with such a high water stress. For example, the USA, south of Europe, near the Middle East, India, northeast of China. Besides this, currently over 10% of gross domestic production are from regions with a high water risk, and this figure is potentially increasing to 46% by 2050. Currently, 4 billion people are facing severe water scarcity for at least 1 month a year, and 500 million people are facing these water scarcity year-round. So these figures are really frightening, but what does that mean economically for you, for example, as PVC producer? So I want to keep it very short here and simple. So it will mean to you that you have to face then higher freshwater costs, higher wastewater costs, and also decreasing availability of fresh water. But what can be done against this? So here you can see a figure with the climate water stress level.
And for that, we are going to have Mrs. Aruna Kumari, General Manager Reliance, who's going to be moderating this session, and the beautiful panel of speakers. We